Hello, this is Isaac, and today we'll be covering Part C, that is questions 21 to 25 of the 2023 CEMC Cayley Math Contest from Waterloo. So without further ado, let's get right into it. Question 21 says, a line has equation y equals mx minus 50 for some positive integer m. The line passes through the point a0 for some positive integer a. What is the sum of all possible values of m? So this problem uses the line equation of y equals mx plus b. X and y are the two coordinates, and y is determined by x times m plus b. But what are m and b? M is the slope of the line, and b is the y-intercept. The y-intercept is the value of y when x equals 0. The equation the question uses is y equals mx minus 50. So on a graph, that would look like, say here is 0, negative 50. We're also trying to find a0, which is anywhere on the right side while also being on this line, because y equals 0 in this equation. So this would be our line. We also have to remember that a is a positive integer, meaning that it's a whole number. Now to explain slope. The higher your slope, the steeper your line. So let's say, for example, you have a slope of 2. That means that from the point it starts, the line will go up 2 and over 1 continuously. So your line will look a little something like this. If you have slope 3, your line will go up 3 and over 1, and will look like this. Whenever slope is a positive integer, that means that it always goes up by the value of the positive integer and then to the right 1. So in this case, m is a positive integer, so it will go up by m and over to the right by 1. Also, anywhere on the middle of these slopes is not on a point. This is important because both m and a are integers, so if it were to work out that a happens to land anywhere in between these 2 points, it would not work because a would be a decimal or a fraction. It would not be an integer. So 3 wouldn't work because if you started at negative 50 and kept going up by 3 and over by 1, 3 is not a factor of 50, so it would not land on a. So that means that all the possible slopes are factors of 50. So we just have to find those to find all the possible values. So 50 is divisible by 1, 2, not 3, not 4, 5, not 6, not 7, not 8, not 9, but 10, 25, and 50. So now the question wants us to add them all up. So 1 plus 2 is 3, plus 5 is 8, plus 10 is 18, plus 25 is 43, plus 50 is 93. And that is our answer. Alrighty, now on to question number 22. The integers 1, 2, 4, 5, 6, 9, 10, 11, and 13 are to be placed in the circles and squares below with one number in each shape. Each integer must be used exactly once, and the integer in each circle must be equal to the sum of the integers in the 2 neighboring squares. If the integer x is placed in the leftmost square, and the integer y is placed in the rightmost square, what is the largest possible value of x plus y? So I'm going to start by drawing the squares and circles. this will be x, and this will be y. And our numbers available are 1, 2, 4, 5, 6, 9, 10, 11, and 13. So we need x and y to be as big as possible, but they're both squares, so that means they have to add up to something else, so they can't be the biggest number possible, 13. We need the sums to be as big as possible as well, because the bigger the sums, the bigger x and y can be. So 13 will go in one of these two circles. So let's just put it here for now. So we need the biggest number possible in y that can add up to 13. So that can be 11 plus 2 or 9 plus 4, and then it just gets way too low. So I'm going to start with 11 plus 2. So we have this side. Now we go to the other side. For x to be as big as possible, the next biggest number is 10. But if x is 10, then nothing can be in the circle because there's nothing available bigger than 10, and 10 needs to add up to something. So 10 will go in the circle. Two numbers that can add up to 10 are 9 and 1. Since 9 is the bigger of these two, it can go in x. 9 plus 1. So now we've figured out the edges, and now we need to figure out the middle, see if it works. So we have 4, 5, and 6 left. 4 is the smallest of these three numbers, so it will go in the square, because if it goes in this circle, then these two need to add up to this circle, so we need 1 plus 3 equals 4, and we don't have a 3. And if it goes in this circle, we'll need 2 plus 2 equals 4, but we've already used our 2, so 4 needs to go in the center. And what's 1 plus 4? 5. And 4 plus 2 is 6. So we've used all of our numbers, and it all works together. So x equals 9, and y equals 11. So the biggest possible value for x plus y is 9 plus 11, which is 20. And that's our answer. Moving on with question 23. In the diagram, ABC is a quarter circle centered at B. Each of the square PQRS, square SRTB, and square RUVT has side length 10. Points P and S are on AB, points T and V are on BC, and points Q and U are on the quarter circle. Line segment AC is drawn. 3 triangular regions are shaded, as shown. What is the integer closest to the total area of the shaded regions? Alright, so I ripped out the diagram to help us on this question. So this is 10, and all the way here is 20. What we need to find out is this little edge length near the end, because then we can find out the area of this triangle, and then subtract it from 10 to find the length of this triangle and this triangle. So what we need to do is find this little length right here. And we know that this is 10, this is 10, this is 10, and this is 10. So how do we find the length of this little thing? Well, we could find the length of the entire thing and subtract 20 from it. Now how do we do that? The beauty of a circle is that you can go from the center to any of the edge points on the circle and they will all be the same length. So if I were to go to Q from B, that's both the radius of the circle and it can be solved using the Pythagorean theorem because it's in a rectangle. So to solve with the Pythagorean theorem, it's a squared plus b squared equals c squared. We'll have a, b, bt, which is 10, so 10 squared, and then b, p, b, b, which is 20, so 20 squared. So now we have to figure out what these together are, so they equal 100 plus 400, which is 500. So c squared equals 500. So that means this line is the square root of 500. So to find this little tiny length right here, we just have to know the full length and subtract 10 and then subtract 10 again, so subtract 20. So this little tiny length is the square root of 500 minus 20. And I'm not calculating the square root of 500 yet, so that our answer can be more precise, which is always what we want in the Waterloo competitions. So this triangle is the same as this triangle. So these two edge lengths are also square root of 500 minus 20. And the area of a triangle equals the base times the height divided by 2. So this is the base and the height. So all we have to do is square this and divide it by 2. And that's the area of the smallest triangle. Now to find the big triangles, we know that this edge length is square root of 500 minus 20. So since this whole length is 10, we can do 10 minus this edge length equals this edge length. So it will be 10 minus square root of 500 minus 20. And it's important that this is in brackets. So to find the area of this triangle, we need to square this, because it's the base and the height. But this time we don't need to divide it by 2, because there's 2 triangles. So we would just end up multiplying it by 2. So our final equation is square root of 500 minus 20, let's make that a little longer, squared over 2 plus 10 minus square root of 500 minus 20 squared. So now it's time to put that into our calculator. So I'm going to put 2 brackets, square root 500 minus 20, closing bracket, squared, divided by 2, closing bracket, plus opening bracket, 10 minus opening bracket, square root 500 minus 20, 2 closing brackets, squared, equals about 61. So 61 is the approximate value of all the area of all the shaded regions, and that's our answer. Now on to question 24. Karina is in a tournament in which no game can end in a tie. She continues to play games until she loses 2 games, at which point she is eliminated and plays no more games. The probability of Karina winning the first game is 1 over 2. After she wins a game, the probability of Karina winning the next game is 3 over 4. After she loses a game, the probability of Karina winning the next game is 1 over 3. The probability that Karina wins 3 games before being eliminated from the tournament equals A over B, where the fraction A over B is in lowest terms. What is the value of A plus B? So the first thing we need to do is go over the possible combinations of her winning. So she has to win 3 games before she loses 2 games. So she could end up just winning the first 3 games. She could lose the first game and then come back and win 3 games. She could win 1, then lose 1, then win 2 more. Or she could win 2, lose 1, and then win another one. Since she's eliminated after losing 2 games, the most she can lose is 1. So the first game, she has a 1 in 2 chance of winning. After a win, she has a 3 over 4 chance of winning. And after a loss, she has a 1 in 3 chance of winning. So in this first one, she has a 1 in 2 chance of winning, and then after the first game, she has a 3 over 4 chance of winning because she won the previous game, and then because she won that game, she has a 3 over 4 chance of winning again. For the next one, she has a 1/2 chance of losing the first game, and since she lost that one, she has a 1 in 3 chance of winning the next one, and then since she won that one, she has a 3/4 chance of winning this one, which she does, and then a 3/4 chance of winning this one. Now it's a 1/2 chance of winning the first game, and then, because she won that one, she has a 3/4 chance of winning, but instead she loses this game, so that means that has a 1 in 4 chance of happening. Because she lost that game, she has a 1 in 3 chance of winning this game, and then since she won that game, she has a 3/4 chance of winning this game. Now she has a 1/2 chance of winning the first game. She won that, so she has a 3/4 chance of winning this game. Won that, once again, a 1/4 chance of losing this game because she had a 3/4 chance of winning. And then a 1/3 chance of winning this game because she lost the previous game. So in probability, when you're finding the chances of multiple things happening, when you use the word and, you multiply, and when you use the word or, you add. So for example, in the first case, she wins this and wins this and wins this. So that means it's this times this times this. So multiplying fractions, you multiply the numerators together. 1 times 3 times 3 is 9. 2 times 4 is 8. Times 4 is 32. Multiplying the denominators together. So this next one, she lost that and won that and won that and won that. So it's all multiplying. Actually, everything's multiplying. So multiplying the numerators together, we get 9 again. And then the denominators together, we got 2 times 3 is 6, times 4 is 24, times 4 is 96, which can be simplified to 3/32. Next, we multiply these numerators together, and we get 3. Then these numerators together make 2 times 4 is 8, times 3 is 24, times 4 is 96, which can be simplified to 1/32, dividing it by 3. Now here we have 1 times 3 times 1 times 1, which is 3. And then 2 times 4 times 4 times 3, which is actually just the same as this one, just in a different order. So 3/96, which is 1/32. So going back to when I said or is addition, we want any of these happening. So we could have this, or this, or this, or this. So we add these fractions together. Since they all have the same denominator, this should be pretty easy. You just add the numerators together and put it over the denominator. 9 plus 3 is 12, plus 1 is 13, plus 1 is 14 over 32. And since it's supposed to be in simplest terms, we can divide them by 2, get 7/16. So that is a over b, and since we need a plus b equals 7 plus 16 equals 23. And that is the answer to question 24. Alrighty, so last question. A set consists of 5 different odd positive integers, each greater than 2. When these 5 integers are multiplied together, their product is a 5-digit integer of the form AB0AB, where A and B are digits with A does not equal 0 and A does not equal B. The hundreds digit of the product is 0. For example, the integers in the set 3, 5, 7, 13, and 33 have a product of 45,045. In total, how many different sets of 5 different odd positive integers have these properties? So first, to solve this question is you have to make a certain observation. You have to notice that every number of the form AB0AB is a multiple of 1001. You can try this out on your calculator. If I do 1001, and I can just do any 2-digit number, like 56, it'll give me 56056. Next, we have to find the prime factorization of 1001. So, it's divisible by 7, and 1001 divided by 7 is 143, and then 143 is divisible by 11, and 143 divided by 11 is 13. So, 1001 equals 7 times 11 times 13. The reason we do this is because 7 times 11 times 13 are 3 odd positive integers. So if we multiply them with a 2-digit odd positive integer, we will get an odd number of the form AB0AB. But we have to multiply them by 2 odd positive integers. So these 2 odd positive integers have to multiply together to create a 2-digit odd positive integer. For example, if we did 7 times 11 times 13, and then we picked 2 odd positive integers that we haven't picked yet, let's say 3 and 5, the 2 lowest that are still greater than 2, it'll give us 15, 0, 15. 3 times 5 is 15, so it's basically like saying 15 times 1001, but we broke up the 15. So we need to find multiple 2-digit numbers like this that can be divided into 2 other numbers. So 15 is the first one, being divided by 3 and 5. It's the lowest one because 3 and 5 are the 2 lowest odd positive integers that are still greater than 2. The largest odd positive integer we can multiply 1001 by to get this form is 97, because if we multiplied it by anything over 100, it would reach 6 digits, which is not possible, and if we did 99, A would equal B, because it would be 99099. Now we need to make a list of all the 2-digit numbers between 15 and 97 that would fit this. So, they have a few rules. There are no even numbers. There are no prime numbers because it has to be divisible by 2 numbers so that we can get 2 extra odd positive integers in this formula. There can be no double numbers, and what I mean by that is 11, 22, 33, 44, because for the same reason that we ruled 99 out, A would equal B. And finally, no repeats of 7, 11, or 13, meaning that we can't use a number that has a divisor 7, 11, or 13. For example, if we did 21, that is only divisible by 3 and 7. Since 7 is one of these, we would have 3 times 7 times 7 times 11 times 13. That doesn't work because there's 2 7s and it has to be 5 different integers. So I'm going to find every possible number between 15 and 97, and if you want to watch that, you can stick around, or if you want to skip that, I'll leave a timestamp somewhere on the video. So since there's no even numbers, I'll just count by odd numbers, so starting with 17. 17 is a prime number. 19 is a prime number as well. 21 we went over has a divisor of 7. 23 is a prime number. 25 is only divisible by 5 and 5, which is a repeat of itself, so that doesn't work. So 27 is our first possible answer after 15, which is divisible by 3 and 9. After 27, 29 is a prime number, 31 is a prime number, 33 is a double number, 35 is divisible by 7, 37 is a prime number, 39 is divisible by 3 and 13, 41 is a prime number, 43 is a prime number, 45 is not only divisible by 5 and 9, but it's also divisible by 3 and 15. 47 is a prime number. 49 would be a double repeat because there'd be 3 7s, so that really doesn't work. 51 is divisible by 3 and 17. 53 is a prime number. 55 is a double number. 57 is divisible by 3 and 19. 59 is a prime number. 61 is a prime number. 63 is divisible by 3 and 21. It's also divisible by 9 and 7, but this case doesn't work because it contains a 7. So that doesn't work, but 3 and 21 does. 65 is only divisible by 5 and 13. 67 is a prime number. 69 is divisible by 3 and 23. 71 is a prime number. 73 is a prime number. 75 is divisible by not only 3 and 25, but also 5 and 15. 77 is a double number. 79 is a prime number. 81 is divisible by 3 and 27. Also 9 and 9, but that's a repeat of itself. 83 is a prime number. 85 is divisible by 5 and 17. 87 is divisible by 3 and 29. 89 is a prime number. 91 is only divisible by 13 and 7. 93 is divisible by 3 and 31. And then 95, sorry, I'm kind of cutting off a little. But 95 is divisible by 5 and 19. And 97 is a prime number, so it doesn't even count. So our actual max was 95. So if we count up all of these possibilities, we have 3 times 5, that's 1, 3 times 9, that's 2, 3, 4, because there's 2 for 45, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So there are 15 possibilities, but that's only for 7 times 11 times 13 plus 2 others. If you notice in the equation, it had 3 times 5 times 7 times 13 times 33. And that works. It makes 45, 0, 45. However, there's a 7, a 13, but no 11. That's because it was multiplied by 3 and turned into a 33. So we need to count for that as well. So the way we're going to do this is by, instead of doing 7 times 11 times 13, we're going to do 7x times 11 times 13, as well as 7 times 11x times 13, as well as 7 times 11 times 13x. X being another odd positive integer. So let's go with this first one. Let's say x was 3. That would mean it would be 21 times 11 times 13. Because we multiplied it by 3, it will end up being 3003 instead of 1001. If we do it with 5, it'll be 35 times 11 times 13. Our next one would be 49 times 11 times 13, because it'd be 7 times itself, 7. But that creates 7007. And because our two smallest odd positive integers larger than 2 are 3 and 5, that would make 15. And if we did 7007 times 15, that goes over our limit. So this and everything larger does not work. Now for these two, we'll have the same possibilities, except since this goes to 3003, it'll have a lower limit. Its lower limit will be 33, because 3003 times 33 is just barely under the 6-digit cutoff. So our lowest number is 15, taking this from this list, and then 27, And that's actually it for this. You might be wondering, hey, we can use 21 now, because it's 3 times 7 and we completely eliminated our 7. And yes, that is correct. But if you notice on the calculator, we do 3 times 7 times 11 times 13 times 21. It works. That's what this would be. That's what this equation would be. But if you notice, it has 7 times 11 times 13 in it, which we already did all of those possibilities. In fact, it was the one with 63. 3, 7, 11, 13, and 21. So we still can't have any repeats of 7, 11, or 13. So this sadly does not work. Next for this one, it multiplies to 5005. So its maximum would be 19, because 5005 times 19 is just barely under 100,000, which is the cutoff. So the only number we have under this is 15. So any higher you go, you won't have any numbers. There's just this 15, and 27. There's 3 possibilities for this. Now if we do 7 times 11x times 13, if x is 3, then 11 becomes 33. And it can become 55 as well. But just like the other one, this multiplies to 3003 because we multiplied it by 3. This multiplies to 5005, so it's going to have the same exact limits. So it can't go any further beyond 55, and it'll have the limit of 33 and the limit of 19. So it'll have 15 and 27. And then this one will just have 15. So there's once again 3 possibilities for 11x. And it's the exact same for 13x. 7 times 11 times 39. 7 times 11 times 65. This is 3003. This is 5005. Same limits. 33, 19, 15, 27, 15, 3 possibilities. Now, what if 2 of these numbers have x? Well, they would both, at the minimum, be multiplied by 3. And if 2 of these numbers are multiplied by 3, that means the whole number will be multiplied by 9. And we could only multiply it up to 5 for it to be possible to have 2 other numbers. So, just like this wasn't possible, having 2 numbers times 3 would also not be possible, so we can be sure that this is all of the amount of possibilities. So we just gotta add those up. 15 plus 3 plus 3 plus 3 equals 24, and that is our final answer. Thanks for watching this video. I hope you learned a thing or two, and I hope you have a great rest of your day.